Hello, Chemistry 111 students. I'm recording a little tutorial to help you with lab number 2, the metrics lab. The pre-lab questions in this laboratory require that you do some error analysis calculations. And I want to show you how to do these calculations the long way with respect to standard deviation, explaining what the equation means, as well as I'm going to show you some shortcuts that you can use using Excel on a spreadsheet. I would like to tell you that you need to, for the first exam, be able to calculate standard deviations using your calculator. So it is important that you understand what the equation means, how to manipulate the numbers in your calculator. Some of you may have standard deviation functions in your calculator. If you're going to use that, I recommend looking in your manual to make sure you understand how to access that. Any calculator that's a scientific calculator should be able to do the standard deviation calculations, as long as you understand how to do the summations and the squares of some of the terms. So let's see how you would set up a standard spreadsheet assignment. First of all, you should put your name on the assignment. Let's say this is Sally Student's assignment. If I want to resize here in cell A1 that I'm looking at right now, if I want to resize that cell, I can go ahead and select this line between A and B and drag it over to change the size of my cells. We'll be doing that a couple times to resize them so that text doesn't wrap over into the next cell. Next, if we had a lab partner that worked with us during lab to help us collect data, we would put the lab partner's name down. Now on a pre-lab assignment, that wouldn't be such a key thing because you did it by yourself, which is what I would expect. But if it was a laboratory spreadsheet and you collected the data with someone else, we'd give them credit for the lab work. But remember, every single person is required to set up their own spreadsheet. You cannot give your spreadsheet to somebody else as a template for them to change. They must design their own. Now you can't work next to one another in a computer lab and both be working on your spreadsheets and giving each other tips. That would be legitimate, but just make sure you aren't copying one spreadsheet where they've done most of the work. So my lab partner, let's say it was Chris Chemist. If it was a lab partner, I'm going to go ahead and resize my cells again. Okay, now we want to put the date that we worked on this, so let's say we worked on it on January 29th, 2013. And I will reference what work I was doing here, so I'm going to put lab manual. And this is experiment number 2, pre-lab question. Number 6 is what most of you are asking for some help with. Okay, and so that would be my title. The title would be okay if you wanted to put it up and to the right a little bit, as long as it can be found pretty easily. If I want to make sure I can find the title easily, I can bold it. I might also bold my name, the student's name, so that we could find that pretty easily. Now, if I had multiple questions in each part of the spreadsheet where I'm doing a calculation with one of the questions for the lab, I'd mark which question I was answering so the instructor, as I grade, can figure out which answers you're reporting in each section of the spreadsheet. So right now I'm going to say again, I'm working on the pre-lab question number 6 on the spreadsheet, so I want to make sure that's clear. Now I want to point out, I'm going to put in some weights that are going to be a little different than your pre-lab to make sure you're actually trying this with your own set of numbers. So these are not identical to the weights that you actually have in your pre-lab question. I want you to do it with the pre-lab numbers that were given in this problem, not with the numbers I'm showing right now. So I'm going to even note that here, numbers changed for example. Okay, so I don't want you to just copy this and hand it in to me like this. So we can put in mass 1, mass 2, mass 3, mass 4, mass 5 for our different masses. If I want to put a subscript after the masses, I can go up here to the formula bar. You'll see that's up at the top right now. I can select the 1 and I can hit font. And I hit that right arrow down at the bottom. That gives me more font options. I'm going to put a subscript here. Now you'll notice I have a subscript in the font there. That could be very handy for putting in chemical formulas. If I wanted subscripts, I can just go over to the font menu, tell I want subscripts. I can also do superscripts for charges, let's say on ions. So you could do that to give some nice formatting in a class where we're dealing with a lot of superscripts and subscripts. A little mail pop up there. Darn it. Okay. So I'm just going to format this so it'll look nicely here. Feel free to fast forward through sections once you see the first example if you don't want to watch everything. Okay. I can also select a cell, such as cell A, that means column A, row 6, A6. I can right-click on that cell and go down to my Format Cells menu, and I can choose to, under the Alignment tab here at the top, I can go ahead and click the Wrap Text button. The nice thing here is if I don't want my cell width to be so large, I can go ahead and wrap the text. I can even hit return. I can go ahead and wrap the text however I would like. Here I'm trying to put some spaces so I see the numbers change for the example on the second line. It just looks a little neater that way, and I can change the width a little bit. I can also center everything by going up to the Alignment section under the Home tab. So I'm on the Home tab, the Alignment section. I can choose to center what I'm working with if I would like. Okay, so my next column, this is going to be column B, is going to be my weight. And you'll notice in problem number 6, they have the weights in pounds and ounces. So I'm going to put the pounds right in column B, and then I'm going to put the weight in ounces in column C. Okay. When we're working with it, we'll want to make sure that we have the weight in one of the two weight units combined. So I'm going to convert them all to ounces here in a moment. Okay, so since I said I was going to use some slightly different data, let's say we have 11 pounds, 10 pounds, 9 pounds, another 10 pounds, another 11 pounds, and let's say our ounces were 6 ounces here, 9 ounces here, 8 ounces there, 4 ounces there, and 5 ounces here. So it's 11 pounds, 6 ounces with one measurement, 10 pounds, 9 ounces, 9 pounds, 8 ounces, 10 pounds, 4 ounces, and mass number 5 was 11 pounds and 5 ounces. I'd like the total weight in just ounces, so I'm going to label column D as total weight in ounces. And I can choose to bold that under the Home menu, under the font, right here. Okay. Now we're going to put a function in here where I'm going to reference cell B7, and I can type in B7. Okay, and you notice it now highlights as blue so you can see which cell you're referencing. I'm going to take B7 and I want to convert that to ounces, so I'm multiplying by 16. The reason I'm doing that, I'm thinking there's 16 ounces per pound, so if I multiply by 16, I'm going to convert that 11 pounds to 16 ounces. Then I want to add the ounce total, which is in column C, row 7, and you'll notice I have a green square there highlighting that section, so I know I'm working with it. Now I can hit enter and I can see that I have 182 ounces for mass number 1, and that's the number I'm going to want to work with. So in fact I can select these cells, which I'm going to have all of my total weights in ounces, and I can go up here to the top and I can put theme colors under the Home and Font section, and I could choose to put that in green if I would like. So those are the ones I'm going to work with. Okay. Now, sometimes I want to be able to see my tables, squares a little better, so we can always select here to Format Cells under the border, and I can choose to put an outline there. So I have some cells I'm working with. And the nice thing is I can hit Control-C, or I can go up to my clipboard to copy and paste, and I can select a cell, such as I do here with cell D7. I'm going to copy that cell, and I can paste it down. And notice I left-clicked and dragged over the cells I want to paste in. So I left-clicked and dragged over D8, and I held the left mouse button down to D11, and I hit Control-V to paste. And now I have my total weight in ounces calculated, and you know it incremented. If we look at each of our calculations, it increments down by 1 as I paste it down 1 row. That's quite handy. It helps us do the calculations very quickly, even in comparison to using your hand calculator. Now, I've had students in the past who felt a little uncomfortable with spreadsheets, but you are required to learn how to do these calculations in a spreadsheet. So I need you to reference your example calculations as to what formulas you are using. So for this case here, I'm going to copy the calculation that I'm doing in cell D7. And to do that, you'll notice that I went up to the formula bar, and then I left-clicked and dragged with my left mouse button the formula in that formula bar. I hit Control Copy to paste it. Then I hit Enter so I don't accidentally select another cell. So I hit Enter first before I do anything. I'm going to click here to the right, and I'm going to show this as my example formulas. Now, if I just paste this in, it actually pastes the formula as it was, and you notice I still can't see, unless I'm looking at that formula tab, I can't see the formula that I was using. So this didn't help me with an example formula yet, because I wanted to show when I print. Now, when I'm printing, I can go up to this formula bar, and if this is the example calculation, I want to show my instructor that I put into the spreadsheet, I would put an apostrophe, and that apostrophe will now tell the Excel spreadsheet to show this not as a calculation, but just show the text of the calculation. So now I have an example calculation shown for the instructor. I only need to show it once if I'm doing the same type of calculation in each of these cells, and I'm good to go. Now, we'll label this as example calculation. Right there. What we're going to do next is, in fact, I'm going to put this example calculation above that column. It's okay, it can be to the right or above, just so it's clear that I can find it. Next here, I want to start doing my standard deviation calculation. And if I look at my standard deviation calculation here, I have it in the green box down here below. My standard deviation calculation is going to use a square root as well as squaring a term, and this capital Greek letter sigma, which several of you have asked me about, deals with a summation where I'm summing up the difference here of each individual measurement. So xi is each individual measurement that we took. That would be the 182 up here, the 169, the 152, the 164, the 181. Those are each xi value. X sub m is the mean of each of these, so perhaps I should take the mean here so I can work with that standard deviation. So my next row is going to be the mean. I want to calculate it in ounces. Okay, so I'm going to go ahead and calculate that mean here below the total weights. So I'm going to put in a formula. Now I could either type in sum up each one of these total weights and divide by the number that I had, or there's often a built-in function in itself for most types of standard calculations. So I'm going to see if there's an average, which is the same as my mean here. Also, there's an average function. So you notice it brings up some functions that it thinks you're looking for. If you're not sure if you have the right function here that you need, if you go up to this question mark on the right-hand top corner of Excel, you can look up specific functions and see the types of calculations they're performing to make sure it's doing what you think it should be doing with respect to the function that you choose. This one I've already checked. We know that it's just going to average the numbers that we pick. Now I can either type in each cell, or what's really handy to do is I can go up to the first cell and I can left click and drag again and select each of the cells I'm interested in. So that's D7 through D11, and you'll notice they're all highlighted by a flashing border. Okay. Now I can either close my parentheses manually and hit enter, or if you do not close the parentheses manually, you can just hit enter and it will automatically do so for you. So we now found that the average, or the mean, of all of our measurements was 169.6. Okay. Now that's going to be my SM value, right? So that's going to be SM. So I even label it here that we just calculated S sub M for our standard deviation calculation. Okay, so in my next column, I would like to calculate SI minus SM. Okay. Okay, I'm going to center that. And so to do so, I'm going to take each individual measurement. So that's going to be equal to, so I put an equal sign telling itself that I'm doing a calculation. I'm going to left click on D7. That's my S1 value, the first of my measured values. So that's S1. I'm going to subtract my mean calculation, which is in cell D, column D, row 12, that I had already calculated. And that's going to be my first SI minus SM value. That's actually an S1 for measurement 1 minus the mean. Now I have to be careful, so I'm going to show you this would be the incorrect way to do this. If we hit Control Copy and left click to select the other cells and paste, it increments, but I want you to notice what's happening. We're not actually subtracting the mean from these other SI values, S2, 3, 4, or 5. And here's why. If I look on my cell, I can go up to the function bar, and this is always handy to click on the function bar to see which cells you're referencing. It incremented down 1 as I pasted down with respect to the measurements, but it also tried to increment down with respect to where the mean was being referenced. So I need to fix that. So this was incorrect. So I'm going to select those cells by left-clicking on them that have the incorrect answers, and I can go ahead and hit backspace or delete to get rid of those cells. I'm going to try this calculation again, but I want to go ahead and fix my mean calculation. If you don't want a cell to increment when you're pasting it in your selections, you can go up to where the cell's referenced, right? Because here we're referencing, sorry, here for the SI minus SM, we're referencing cell D7, which we want to increment. So I'm going to leave that alone. And we're in here, surrounded by a green border, we're referencing the mean, the 169.6. I don't want that cell to increment. So what I can do is put a $ in that cell before D. That tells me not to increment the column should I paste to the right or to the left of the original calculation. That's not the problem, though. We're actually incrementing with respect to rows as we paste down. So I want to also put a $ before the number. So if I put a $ before the letter and before the number with respect to the column and row reference, this will prevent us from incrementing this cell. We will always reference this cell as we're using these calculations. So let's go ahead and hit Control Copy on that calculation now. I'm going to left click and select my cells. I can Control V to paste, or I can be pasting up here on the paste menu under the clipboard. Okay, and now you'll notice that we have subtracted the correct mean each time. In fact, I can reference this. I can go look up at the formula bar again, and I can see I'm referencing and incrementing down the measurements, but not incrementing with respect to my mean. So we've done what we intended to do here to find each of the SI minus SM values. Now I want to take the square of those differences, because if we look down here in the standard deviation function, down here below, SI minus SM, we're squaring each of those terms for my standard deviation. Okay, so what we will do then is copy that over, and I'll go up to the formula bar to edit the text. I'm going to put a left bracket and a right bracket. I'm going to indicate an upper caret 2 to indicate that it's being squared. You notice that our superscript isn't quite correct here, so I'm going to select the sections there and change the font so it's not a superscript for that bracket. In fact, here is a case where I don't have to use the caret if I don't want to. I can put a superscript for the 2 and get rid of the caret entirely if I don't want to use that shorthand notation. Okay, so now I'm going to square each of these terms to the left. Okay, so that's going to be equal to my 12.4, so I just clicked on that cell to reference it. It's flashing now. I want to square it, so I can put an upper caret 2, and that in its cell indicates that I'm squaring that term. Okay. So I Control Copy, and I'm selecting down to paste, so I'm just going ahead and incrementing down. And luckily there I didn't need to freeze any cells, so it was a pretty fast calculation. If I want to center these numbers, I can always go to the Alignment tab under the Home tab of the Alignment section, and I can center everything. I want to show these reference calculations again, so we're going to keep showing example calculations here at the top. Sometimes I'll show them to the right if I don't have multiple rows of calculations. So with respect to those sample calculations, I'm going to go in, select off my formula bar, hit Control-C to copy, or I can copy off my menus. And then I want to hit Enter before I click on anything else. If you forget to hit Enter before you click on another cell, it tries to reference that cell and will erase your formula. You can always just undo that up here if you made a mistake with the back arrow. Okay, so I'm going to paste in that formula, but I want to show the text, so I put an apostrophe before it. I'm going to do the same thing with these other formulas. Control-C to copy, Enter. I'm going to go ahead and paste it. I need to go back to the formula bar and put an apostrophe in, so now I show the formula. I want to also show these cells with borders, so I went up to my font and my shortcut to borders. Okay, so now I have each value squared. You have to love lots of emails. Okay, now what I want to do then is know what n minus 1. N is the number of measurements. So if I want n minus 1, let's have our little reference to n minus 1 over here. So n minus 1 is going to be equal to the number of measurements that we took. So that's going to be 5. So it's going to be 5 minus 1. Okay. I could have also, there's functions built into a cell that would also have summed up the number of measurements if I select these columns, but for a short number like this, I'm not using that. If I had hundreds of measurements, I might use that function built in to count my number of measurements for me. We're not doing that this time. So we have n minus 1, 5 measurements minus 1 is 4, so that's my n minus 1 reference. Okay. And then we want to take the square root of that division. We actually need to sum this all up. So what I'm going to do here is take the sum, that's going to be the capital Greek letter sigma here, of all of my individual measurements that have been the difference in a squared. So I'm going to go ahead and sum those. Okay, so I'm doing the summation part. So that's the entire top part of this fraction before the square root and before dividing by n minus 1. Okay, so when I type in that function, it's going to be equal to, and there's a function called sum. I'm taking the sum of all of my xi minus xm squared measurements. And so I can left click on the first one and drag down to my F11 cell, and then close my parentheses. And that went ahead and summed up all of those values. Okay. Now I can also, at this point, calculate the next step. I'm going to have that as the sum. I'm going to show parentheses to indicate I did all of that first, then divided by my n minus 1. Okay, so this is just equal to our previous calculation in the G7 cell, divided by my n minus 1, which I'm going to reference n minus 1 is 4 here, or I could have typed 4 in. The nice thing with referencing this is if I change the number of measurements and change n minus 1 in the other location, it would update automatically for me in the Excel spreadsheet, which would help prevent errors. Okay. Now, I need to take the square root of all of this. I'm doing this all one step at a time. Realize if you're confident with Excel, you could have done this all in one formula calculation for a single cell, and it probably would have been quite a bit faster. But I want you to see kind of what you would be doing on a calculator with respect to individual calculations. So this is actually a longer spreadsheet than you'll end up forming in most cases. Okay, so I'm going to take the square root of that. And there's a built-in function square root that we're going to be using here in a second. So I'm going to use the square root function. See, it says it returns the square root of a number, so this is the one I want. And I'm going to reference where I've already summed everything and divided by n minus 1. I'm going to close the parentheses here. And you notice we have far too many significant figures. If you ever want to change the number of significant figures that you're dealing with, we can go up to the we can right-click on the cell, go to Format Cells, and we can go to the number, and under the number we can go ahead and select the number of significant figures that we wanted. So if I only wanted to show 2 significant figures in this case, which isn't quite right for the number that we have in this actual calculation, but if I wanted to show 2, I could just select that. And so for final answers, try to select the correct number of significant figures that you're showing in the future. We will cover significant figures in lecture here shortly. Okay, so that gave me my standard deviation that I should have here. Okay. So I could have also calculated my standard deviation, S, with a built-in function, which would have saved us a little bit of time. But it wouldn't have shown you how to do the individual calculations with the summations and everything on your calculator, which is why I did it the long way first. So if I want the standard deviation with respect to our measurements in ounces, I'm going to label that here. I'm going to bold these, since these are all some important measurements that we're taking. That's going to be equal to a function for standard deviation. And standard deviation is the usual one that I use. Standard deviation A is a good choice here. I'm going to choose standard deviation A, though standard dev will actually give you the same one for this calculation. Standard deviation, I'm going to select the numbers I want the standard deviation of. So I'm left-clicking on cell D7 and dragging down to D11, so I should have a flashing border around the numbers I'm referencing. Since they're in ounces, that's the ones I wanted to pick. I pick enter, that closes the parentheses, and we see we get the 12.5 again. It just hasn't been rounded to significant figures yet. So if we did it right, they should have been the same number, and indeed they were with respect to our spreadsheet. Okay, so I showed you the long way. Once you convince me on this first assignment that you can do this calculation this long way, you can do each individual step, and you understand what the summation sign means and what SI minus SM means, you can go ahead and use the shortcut standard deviation built-in formula on Excel for the rest of the course. I would like to remind everyone, as I mentioned at the beginning of this tutorial, that I expect you to be able to use your calculator to calculate standard deviations for a group of numbers on the first exam. You will not have access to a spreadsheet, so it is important that you understand the formula and how to calculate the standard deviation with the formula. We'll talk a little bit more about it in lab, just to remind you too, in the metrics lab. Okay, now once I have the standard deviation, that's going to give me a little bit of knowledge with respect to my error. And in our laboratory on the metric system, we talked about precision versus accuracy. Standard deviation gives me an idea of precision. How scattered are my measurements from one another? Are they closely spaced together? If so, the standard deviation should be small. If their spacing is quite far apart with respect to the measurements, then the standard deviation should be quite large. But it doesn't tell me about accuracy, which would represent how close we are to a true value. If I want to understand accuracy, I have to use percent error, and you'll notice with percent error here, we're going to take the measured value that we're looking at minus the actual value divided by the actual. So we don't have a true value actually for problem number 6. I can't report a percent error because we don't know what measurement for the weight of this item was the true weight. Let's say though we had sent out, I believe it was a backpack on problem number 6. We sent out this item and we wanted to find its true mass. I'm going to say mass true up here at the top. In fact, let's put that at the bottom down here. That's the percent error. Let's say mass true. That's going to be a reference mass that somebody's told us is measured as carefully as possible, that we really trust. Perhaps at the Institute of Standards they have some measured masses that are scales that have very, very low error with respect to the scales when their calibrations. And so maybe somebody's measured this and they said, well, it's actually going to be, with respect to as reliable numbers as we can get, it's going to be 10 pounds, 6 ounces. I'm going to go ahead and perform our calculation to find that in total weight in ounces. So we're saying the true ounces is 166. If we actually knew that were the case, then your percent error would be my measured value, which I'm going to take the average of all my measurements here. That's my mean. I'm going to subtract the actual, which is the true value we're considering true. And many times you won't have a true value in lab. If that's the case, you cannot calculate percent error without the true value. You can only calculate standard deviation, which still is a good indicator of how careful you have been in lab with respect to reproducing your measurements. Now I want to put a left and right parentheses here so that I take the difference from my percent error calculation before I divide by the actual. So I'm going to divide by the actual, the 166 again. Okay, and then I want to multiply by 100. Okay, so my percent error with respect to my measurements was 2.2% roughly. And I could go ahead, if I didn't want to show all these digits, I could right-click, format cells, go to the number, and if I only wanted to show one decimal place, we would do so. And normally I would aim for changing the number of digits to be the number of figures we're dealing with. If that were the case here, we would actually be dealing with having no decimal places with respect to these ounces, so I would have reduced that even further. Okay, once I have my percent error, what I might want to calculate is my percent relative standard deviation. I calculated my standard deviation, but I haven't calculated my percent relative standard deviation. My percent relative standard deviation is going to be in my S value. That lowercase s represents the standard deviation that we calculated here in the green equation box. And then I divide by et sub m. Remember, that was my mean value for all of my measurements times 100. So it's a very simple calculation. So I'm going to go over here, and so my percent relative standard deviation is going to be equal to the standard deviation that I've calculated in either of the calculations. They were the same value. Okay, and then as you recall, we're dividing by the mean et sub m, right? So I divide by my mean that I've calculated over here in D12. Okay, and then I multiply by 100. That's going to give me my percent relative standard deviation. I could go in here, format the cell again, and change the number to however many decimal places I wanted to report. And I would aim for significant figures normally, but here I just want to give you an example of changing the number of decimal places shown. So we have our percent relative standard deviation, a true value. For problem 6, I don't expect you to use a true value at all, but I do expect you to calculate the standard deviation, which you can do so without the true value. So you should be able to do that. You notice I didn't show all of my formulas yet. Let's go in and make sure I've shown my example calculations for everything. So I want to show my instructor. Whoops, see, I forgot to hit enter there that time, so let's back up. I hit Control Copy, then enter before I click on another cell. Then I paste. And I need to put in the apostrophe in the formula bar here at the top to show text. I'm going to do that for each of these calculations so I can reference that I know how to enter the formulas and that I haven't done it on a calculator to dodge doing it on Excel, which I have seen students do in the past. I want you to learn to use it on Excel. Excel actually will help save you time in the long run once you train on Excel a little bit and practice using it. Okay. I'm going to go ahead and show those calculations for standard deviation here when I use the built-in function. So I want to go ahead and go to the formula bar again, select, and sometimes I'll show it to the right if I have room to the right. So I'm going to show my calculation here, put an apostrophe in, and the formula bar that shows me the standard deviation function was used. I knew how to use it, standard deviation A. Okay, I can also see what I did for the percent error calculation and the reference cells that I was using. So I'm going to copy those, paste it to the right, and it's just to prove to your instructor as I'm looking at this that you did know how to put those formulas in. So I'll do one more for my percent deviation, relative standard deviation. Okay, and if these are the most important numbers I'm reporting for my grade, standard deviation and percent error, I might bold those, or I might even highlight them here under the font menu with yellow, so it's easy to find that those are important. Okay, and I could also make sure that I edit under the font menu. Whoops, under the font menu here at the top. I could go ahead and select my cell borders just to try to make it nice and neat. Okay. Now, if I wanted to print this, I would go up to the main menu, go on the left-hand side, go to Print, and I want to preview it to edit how I want it to look. Right now, it's going to go ahead and show this vertically, which would cut off the edges. So I actually want to change the page setup so it's not a portrait setup. So I hit Page Setup here at the top. I want to go to Landscape and fit to 1-by-1 page, assuming there's not too much data that it would cause the numbers to be too hard to read. If it was going to be that case, try to format things so that I can read the font sizes and no smaller than maybe a font 9 size when you print it, but I can put it onto a single page. So this would be about the maximum that I would want to shrink it down. So normally I might print this as 2 pages because that's quite a bit of information there. So it gives me a view. I can close the print view, and I can go ahead then and print if I want to, and I can go and hit OK, and I'll keep that landscape format. There's another way to show all of your formulas that you're using in your cells. That's going to be using the tilde squiggle that they use in Spanish above some of their letters. That's on the left-hand side of your keyboard right above the tab button. So if I hit Control tilde, it actually, you will see all of the formulas shown in the cell. So if you want to print your spreadsheet with all the formulas shown one time to show you're putting the formulas in, and then print it just with the numbers the second time, that would be okay, and that could be substituted instead of showing all the example calculations, whichever you feel more comfortable with. So what I typed in order to do that, I didn't type it in. What I pushed was my control button, and then while I was holding my control button, I also hit the tilde button, or tilde, depending on your pronunciation. So I pushed those two in order to change it, and I can hit them again. Oops. I can hit them again in order to change everything back and not show the formulas. I need to see your numbers and the formulas, so make sure you give me both if you decide to do it that way so I can see all of your answers, because it doesn't do me much good if you send this sheet in as the only spreadsheet where I can't see your standard deviation or percent errors or percent relative standard deviation, so I would need both in that case. Either be acceptable. If you have additional questions about using your spreadsheet here for the pre-lab for experiment number 2, let me know. I plan on doing a little follow-up tutorial later on this week for the post-lab questions for setting up a spreadsheet as well, to kind of show you some example data and how it can be formatted. So we'll see another one of these if you'd like a little more help. I hope you found this useful. Let me know if you like these types of tutorials, and I'll try to put more into the course for you. Thank you very much. Bye.